In question 8, the diagram shows two identical circles intersecting at points A and B with centers at P and Q. The radius of each circle is R and the distance PQ is 5 upon 3R. In part A, we have to find the perimeter of the shaded region. Now, to find the perimeter, it means that we'll have to find the arc lengths of AB from the circle with the center P, and the arc length of AB again with the center from Q. We can see that both of these arc lengths will be exactly of the same size, as both the circles with center P and Q have the same radius. Now, to find the arc length, we'll first have to find one of the angles. So if I make a line from A to Q, this length will also be R. To find this angle, we can apply the cosine rule, as we already have these two lengths as R, and the length of PQ is 5 upon 3R. Or we can make a straight line from A to the line PQ. This will make a right angle up here, and the length, let's call this point as X. The length PX will be equals to half of 5 upon 3R. So we can say that the length of PX will be 5 upon 6R. Now, to find this, the angle APQ, we can use opposite or hypotenuse sine theta to find the angle. So for angle APQ, this length PX is 5 upon 6R. So as it is adjacent to this angle, let's call this angle theta. As it is adjacent to the angle theta, we can use cos over here. So this angle will be equals to, so we can write cos theta will be equals to the length of PX, which is 5 upon 6R, upon the hypotenuse, which is R. So R and R will cancel out, taking cos inverse of 5 divided by 6. So this length will be 0.58568. So the angle theta is 0.58568. We can round it off to make it 0.5857. Now, to find the perimeter, we already have this angle over here. The length from P till this point will be R as well. So let's call this point as, this point is C. So to find the arc length C, we can use the formula S equals to R theta. So finding the arc length AC, we can use the formula S is equals to R theta. Now the radius is R and theta will be 0.5857. Now, once we have the arc length AC, we can, as all of these arcs will be of the equal length, so we can multiply it by 4 to get the total perimeter of the shaded region. So the total perimeter will be equals to 0.5857R multiplied by 4. So multiplying 0.5857 by 4, the answer will be 2.3427R. Rounding it off to 3 significant figures, the final answer will be 2.34R for the perimeter of the shaded region. As we have to give our answer in terms of R, so we'll leave it as 2.34R. In part B, we have to find the area of the shaded region in terms of R. Now, to find the area of the shaded region, what we can do is, we can just take the sector APC. We can find the area of the sector, subtract the area of the triangle APX. So we'll get 1/4 of the shaded region. Then we can multiply our answer by 4. So first, finding the area of the sector APC. So area of sector APC will be equals to 1 upon 2 R squared theta. So R will remain as it is, and we already have the value of theta, which was 0.5857. So 0.5857. So 0.5857 divided by 2 will be, so dividing 0.5857 by 2, the answer will be 0.29285. So this will be 0.29285 R squared. And now finding the area of the triangle. So the triangle is the triangle APX. We have the two lengths between the two lengths R and 5 upon 6R, and the angle theta, which is 0.5857. So for finding the triangle area of the triangle APX, we'll use the formula half AB sine of C. Now, as one of the lengths is R and the other length is 5 upon 6R, and the angle will be 0.5857. So substituting this in the calculator, we will get sine of 0.5857, which is 0.5527, multiplying it by 5 and dividing it by 12, we'll get 2.303 R squared. Now for finding 1/4 of the shaded region, so subtracting these two areas, we'll get 1/4 of the shaded region. So that will be equals to 0.29285 R squared minus 0.2303 R squared. Subtracting this from 0.29285, the answer will be 0.0625252 R squared. And then finally, the shaded region will be this answer multiplied by 4. So the final answer for the shaded region will be, so the area of shaded region will be equals to 0.06252 R squared multiplied by 4, which will be equals to, so multiplying our answer by 4, we'll get 0.2500 R squared. So we can leave our final answer as 0 to 3 significant figures. It will be 0.250 R squared for the area of the shaded region in terms of R squared.